Can everybody hear me okay? Okay, cool. All right, I'm going to talk today about building a bot with Cloud Functions. And my name is Brian, the CTO of Begin.com. In a former life, I used to work on Apache, Cordova, and PhoneGap. So that was neat. And I liked it. It was fun. I did a lot of mobile stuff, and we got acquired by Adobe in 2011. And they made me into a manager, which was not great. And part of it, they were like, "You're a product manager." And I'm like, "What's that?" And I stopped writing code for a while, which was kind of nice. And they gave me the opportunity to really start learning about the market and figure out what mobile was about. And so I started digging into mobile. And I discovered in 2012 that the App Store was starting to flatline. And this isn't talked about a whole lot right now, but App Store in 2012 added 100,000 new apps. The App Store in 2011 added 100,000 new apps. And so there was a clear indication that growth had stopped in the App Store. And being the product manager on PhoneGap, I was like, well, that's not good. So what's going on? What are these people doing? Like, where are they going? And it became really obvious that people were moving over to messaging apps. And we didn't really have a conclusion about that. We still probably don't over at Adobe. That's their problem now. And so more and more I was getting excited about messaging apps. And all of a sudden everybody just goes fucking crazy about bots. Like everybody is losing their mind about bots. Slack comes out, Facebook's got their bot thing, Kik's doing bots with kids, Telegram's got bots that are like crypto friendly. Microsoft's like, we like bots. No one cared. Amazon, Google jumped on board because everybody else was there. And it was becoming clear to us that more and more people were spending more and more time in their messaging apps, and it's obvious that these APIs and these places are a vector for new types of applications. And we started to feel that maybe in Slack there's an opportunity to get into the productivity tool space, which is a pretty large incumbent market, but also a very large market itself. Does everybody here use Slack? Yeah. Does anybody not use Slack? Someone on IRC here? No. That one dude, of course. There's one dude. So chat ops is a thing. Devs have been doing this for a while, but IRC is not friendly. So people weren't into that, but they are into Slack. You get immediate feedback. You're able to react to your team in real time, and you have better business ops as a result. Kind of also nice if you have a good bot. You don't have to fill out a web form to do something. Who here uses Jira? And keep your hand up if you like Jira. Right. So there's no hands up for the for the audience or for the film. So now we can just use plain language and interact with our computers directly, and they'll figure out the right thing. So this feels like a big shift, and that big shift is all about speed and your ability to execute faster, and that makes sense to us. So we were like, all right, we're going to do this thing. We're going to go pick a fight with the productivity market. We're going to get a cool-ass domain. We're going to be a Silicon Valley startup. And we're going to be fast as fuck, because that is the first rule. We got to understand natural language really well. Can't have any user interface. This is sort of like our driving user experience requirements for the bot that we're going to build. And as every software developer knows, the chief cause of all of our problems is the last solution that we picked. So I used to do this. I used to actually rack physical servers, putting them in a rack and plugging in Ethernet cables poorly, not labeling them. That didn't work out. We scaled that as far as we could, and then we started adding more and more RAM. We're like, well, the server just can't take any more RAM, so we started to scale horizontally, and we made these stateless apps, and that didn't really scale that super well. We started using commodity servers. That didn't, that became economical, but only for big providers, and so virtual machines kind of became the thing. Virtual machines are good, but virtual machines are very slow. And if you're deploying a large fleet of things and you want to have zero downtime, you have to do a rolling deploy. And often a deploy window across servers can be linearly longer, upwards of 20 to 40 minutes for a single deploy across 3 servers, and that's not uncommon. So containers came along, containers like Kubernetes and Docker, and everyone was really excited. We can start these little things up super fast and maybe solve that problem, but there appears to be this ever-tightening cycle that introduces the idea of cloud functions. And cloud functions kind of flip the whole model on its head and say the smallest unit of compute is no longer your application, it's the function itself. If you pay attention, these three things are a metaphor for a server. And this thing is nothing like those things. And that's an important thing to note. Cloud functions are entirely different than the server. So we think this is going to bring some pretty big advantages to the players that adopt them. We have characteristics in cloud functions like immediate deploys, isolation between endpoints. I have seen this happen, and I actually remember an awesome story from Mike Britton, who used to be the CTO of Etsy, where he was telling me about how his favorite three-arm sweater bug. So they have at Etsy, when you bring down the servers, they have an honorary sweater that's got 3 arms. And if you bring down the system, they give you that sweater. It's an honor to get it. They have blameless postmortems, but they do have a funny sweater they'll hang over your desk if you fuck up. And his favorite one was a change to a CSS file kicked off like a cascading set of failures and brought down the whole website. And that's not actually that surprising, because if your smallest unit of computation is your entire application, if you make a mistake in there, every endpoint is coming down. Cloud functions, you don't have this problem. We have an isolation between each of these endpoints, and so you will screw something up, but at least you don't screw everything else up when you do that. And this is a big deal. This means that we get a lot more speed in our iteration. The other big one is that you get more at-bats. If you can deploy multiple times an hour, you can iterate faster on your product, you can find product market fit quicker, you can outmaneuver your competition. So for us, this just seemed like the smartest thing to do. We're going to go into an incumbent market, we're going to build a new type of software, and we're going to adopt a new software paradigm. What could go wrong? It's going to be all roses from here. So yeah, you get these awesome benefits. Cool, we're convinced. This is like, at this point I think it's like late 2016, and I'm like, we're gonna build a bot. And we're gonna do it with cloud functions, because that's gonna kick ass, and there's gonna be no problems. We also realized that we need to do NLP, or NLU, which has become a more popular way of saying NLP, which is natural language understanding. And our bot's a productivity bot, and so it needs to understand millisecond precision date times from natural language, of course, because that's important. And at that time, Slack had a client, but it was written in CoffeeScript and had no tests. And so I didn't have a lot of confidence in it. So we started off by trying to do what most people do in the industry, and that's reuse whatever the hell we could find laying around. And there are a few cloud-based natural language projects out there, and most of them are actually really good. Like they work super well. Problem is they introduce latency. You have an HTTP request between you and actually getting a result, and that's going to take a second or two. Slack's API, you have 3 seconds or they start retrying. So if you've already eaten up a second figuring out what they said, then you've basically turfed yourself. And worse, you don't want to reply multiple times, because then you have a chatty, annoying bot. So we couldn't use a cloud-based natural language service, but we did end up sponsoring the development of a library called NLP Compromise, which is a JavaScript library that does natural language processing. And so we can run it on the client, we can run it on the server. It's super small, and it's been really good for us. So you give it a string, and it ascertains some meaning from that string. I won't go too deep into the code examples. These slides are all, they're all linked up. So if you care to, you can go check out these libraries later. All of our stuff is Apache licensed, so it's open source and free. So that was good. We figured that one out, and we managed to whittle that library down to about 200 kilobytes. So we're happy with the performance. It'll run on our website. It'll run on our servers and talk to Slack with good speed. We really didn't want to get into this one at all. Time zone math with JavaScript is why I'm balding. And so there's a really popular library. Everybody falls back and they're like, let's use Moment.js. And Moment.js is a great library, and I have only respect for the developers that worked on it, but Moment's got a pretty big payload. It packages its own time zone database that goes back to the 1800s. And we decided that we don't need to do daylight savings time calculations from the Victorian era in our bot. So we opted out, we forked it, and we hacked it up, and we created our own solution. We call that Spacetime. And Spacetime clocks in. It has almost the same API as Moment Time Zone, but it only works from 2016 onward, but it's 35 kilobytes. So we get a little bit better of a speed boost out of it. I think Moment clocks in at about half a meg. Maybe this is a problem, maybe it isn't. But if you're developing Cloud Functions, you have this weird characteristic where you get cold starts, and the cold starts are kind of webby in a way. It's your first time hitting the function, it's going to be a bit slow. And weirdly, if you're under 5 megabytes, roughly, you're sub-second. And so every little kilobyte counts. And we need to whittle those down. This is also, we're building a web client, so we wanted it to work, client side. I explained this earlier, but like CoffeeScript, I love it as a language. I think Jeremy Ashkanis is one of the best programmers living. It's a wonderfully written project, but Slack's use of it for their original client was not that great. It was missing a lot of tests and it wasn't so good. This isn't the case anymore. So don't take this library as some kind of gospel that you have to use. There's a ton of libraries. There's one in particular I think that you probably should use if you're getting into this, called either Slap or Howdy's bot kit. But we wrote our own Slack client library called Slack, which was funny that wasn't taken yet out of NPM. So it implements the entire Slack API. So Slack, this is actually a pretty fun story. Slack has really good documentation, and by really good documentation, I mean they have really semantic HTML for their documentation. So I scrape their website and I generate the client by doing that, which sounds horrific, but it's been working for 2 years. So I'm okay with it. It's better than implementing a client by hand. We basically end up mocking out their API word for word, so it works the way you would think it would. It's been good for us. We like it. I have no idea how big it is, but it's not very big. Like, it's definitely sub 50 kilobytes. And it runs on both client and server, and we've tested it, so there's that. So this is important for me to say in this particular meetup, because if there had been a solution at that time when we were doing this development, I would have been using it, and I'd be presenting about serverless right now, but we started roughly around the same time. So we ended up, first of all, I was in denial. It's like, we're not building a framework. I just did that at my last job, and it was PhoneGap. It was a fucking nightmare. I'm not doing that again. I don't want anything near the developer tool space, and we're not building a framework. I kept swearing it up and down. Turns out, even if you say you're not building a framework, you're then building your own framework internally, unless you're adopting one. So this is not something I recommend doing, because it kind of doubled our work. We call it Arc. It's at arc.codes. I'm not going to go super deep in it. Effectively, these things generally work the same way. This works very similarly to how serverless itself works. You have a plain text manifest file. Instead of YAML, we invented our own syntax, which is its own story. Once I'm drunk enough, I'll tell you about it. We have workflows for generating code, deploying it. And we had to do this, because we ended up in a situation where we started to get, well, at first we thought we could just manually provision endpoints, and I think we got to about endpoint 80 when things started to fall apart. So just don't do this. Like, use serverless or use something else or whatever, but don't manually configure your business. Our manifest file kind of reads like plain text, so you got like a name, and this is actually our bot. So we have text HTML routes, and each one of these things gets mirrored on the file system as a cloud function. So it looks kind of weird, and there's a bunch of different stuff here. You can see that we support schedules and SNS events. This single ARC file encapsulates roughly 10,000 lines of logic, though. And so even though you don't know how ARC works, and even though you don't know how our bot works, you super do know where to start just by reading this file. So that was a big thing for us, and you get the same thing out of YAML. We used to have these long deployment cycles that were fraught with errors and lots of issues, and this would be the same thing no matter what framework you were using. The inconsistency of infrastructure became a huge issue for us from bug traceability. So like, we'd think we had something fixed when we really didn't. And our reproducibility was really bad. And when you can't deploy fast, when you can't find your bugs often, your team gets demotivated and they get sad. And then you just have this sort of impending sense of doom. After we introduced even just this small amount of tooling, things got a lot better for us. And we're a great deal happier for it. Like, I'm almost 40 and I'm still learning lessons the hard way. It's sad. So the first piece of advice, you have to have isolated development, staging, and production environments. You can't not do that. And we didn't. We had a bot and we were deploying to it like cowboys and it was great. And then, we had an issue. And this is another interesting thing about Cloud Functions. So we had an issue, a security issue actually, and we surfaced it and we were terrified. Like Slack themselves were using our bot. Oh my God, there's a security issue. The world's gonna end. And so I took that endpoint down, and then I realized I had like 30 other endpoints I had to take down. And I had no way to do it because nothing was automated. And so like these things are fucking resilient. Like, it's hard to bring down a Cloud Function. And once that shit's deployed, it's up there. And they're all like independent of each other and they're totally isolated. So yeah, my recommendation is to have isolated staging and testing environments right away. With Slack, they don't make this super easy either. Unfortunately, we actually have to register a completely separate bot with a completely separate set of URLs in order to have staging and production. I've been asking them for quite a while to give us some toys to make this better. The other bit with Slack is it is not latency friendly, and also humans aren't either. Nobody wants to wait a few seconds for a bot to respond, and so pretty much anything your bot should do should be with an optimistic update. So if you say something to a bot, it should immediately respond, yo, I'm checking that out, like whatever. Like, just give it some static message. It doesn't really matter because you can replace it in a couple seconds after that. But if you don't do an optimistic update, it feels slow. And if it feels slow, no one's going to use it. And especially in our case, we're entering into productivity. Like, our big win's going to come from being faster than everybody else. And this connects back to that. You got to keep your Lambda functions small. You can't have a Lambda over 5 megs if you want to be sub-second. Now, this doesn't have to be the case if you have a scheduled Lambda or something that doesn't need to immediately respond to people, like an HTTP endpoint. But for the most part, you don't want to load these things with a lot of libraries. I've been using Daisy Disk lately to just look at our Lambdas to see what the hell goes on. We're node-based for the most part. And people publish stuff in their packages that they don't need to, like full test suites and like, mock data and like whatever. And so like a couple layers down in that node modules folder, you can get some pretty big payloads. I'm pretty sure that Serverless takes care of this by compiling out your function. We don't do that, and so we have to keep our Lambdas just plain small. You've probably heard about the cold start problem if you're at this meetup, but it is a problem. Lambdas are fairly random in how quickly and often they can start up. And then there is a hack. You can just ping your Lambdas every couple seconds and keep them alive. It's not too hard to set up, and I think for your hot paths you should do that until they fix it. I've heard that Azure functions are actually going to be fixing this very soon. They have a solution, and this one I love too. They were like, we're going to charge extra for it, and I'm like, yeah, do that. Like, I'd pay for it, right? Like, add value. I'll give you money. When we first started, we were on that whole train about like, AI is the future and natural language. And I think those things are probably true over a longer period of time, but UI is okay. Like, it's totally okay to respond with a button, like yes or no. It's people are not upset about that. It's worse to be like nebulous and ask a question of a user and not give them a way to like immediately respond. I think if anything, you want more UI, which is interesting because I think when conversational started to become a thing last year, everyone was convinced that UI was on the way out. Slack introduced buttons. It simplified our app immeasurably. It was a good thing. I also think command-based interactions are okay with bots, and this is probably a controversial opinion that maybe even all of our team wouldn't necessarily agree with, but if you have a single command and the bot does a thing, that is a very satisfying user experience. If you have a bot that just talks to you and you talk to it, now you just have another person you have to talk to, which is fine, but maybe not what you want to do. Like, if I just want to deploy something, I just want to say, hey, bot, deploy. Like, so command-based interactions are okay. You don't have to feel bad if you don't have like strong NLP in your system. This was really big for us. So at the very beginning, we were certain that we needed to have these performance budgets. We couldn't be a successful startup in the productivity space without making speed our priority. And so right from the beginning, we want to have sub-second responses from our bot all the time. This changed the focus of our scope and product so much because we had a forcing function staring us in the face. Every time we had a product meeting where it was like, we're going to add some stuff, we're like, cool, we're going to have to remove some stuff too because like we got to be quick. And that's all there is to it. Well, and then we started to get really clever with like, optimistic updating and background processing and that kind of thing. I think this is my biggest lesson this year. It's a lot harder to build something that's fast and simple than it is to build something that's large and complex. The nice thing about Cloud Functions is that you get forced into this naturally. It's a side effect of the way that you're designing your application. And I can't speak enough to how important this is. So there's an old John Gall quote, which I think applies really well, that a complex system that works is invariably found to have evolved from a simple system that works. Complex system designed from scratch never works and cannot be patched to make it work. You have to start over with a simple system. This is the beauty of Cloud Functions. Like no matter how you're approaching this, you have to think about these things as each individual atomic unit of code, and you get this as a side effect. And it's a good side effect. Kind of what you want. Patience, non-attachment, domain broker, and an Excel spreadsheet with several thousand lines of single word verbs that we thought would be maybe acceptable that we could spit into a company. It was mostly my co-founder that did this, and it literally took us like half a year. And we had this huge Excel spreadsheet, and we were tracking people, and we were chasing it was weird. It was super weird. It was a great domain, though. We were stoked to get it. No, we scripted it against the AWS SDK because CloudFormation didn't support Lambdas at the time. And so it's all code. It was actually a lot of bash scripts at the beginning, which I probably shouldn't admit, but it was the quickest way to do it. And then eventually we moved from bash scripts and text files into this more tightened up reality where we've got NPM scripts and just pure JavaScript code. It's not as fast as I would like it to be, and I was actually just talking to Austin about this. The API gateway has really strong rate limiting, and so you can set up and tear down an API in about 10 minutes. It's the fastest I can get it. If you poke your AWS Cloud Rep, you can get better rate limits, but not greatly better rate limits. So I expect that's going to get better with time, though. Yeah, I did. I really wish a lot of this stuff existed before. I like SAM. I feel like it's kind of like showing up a little late to the party, but it's good that they added it. It's interesting to me that Amazon's got just so many things and they're very additive. Like CloudFormation's from 2010. So Amazon's been doing infrastructure as code since 2010, which is like, I figured out infrastructure as code in like 2014. I mean, that's a very encompassing question. It's a lot of it, I'd say. We didn't really recognize how much we were biting off when we bit it off, and then we were like, well, let's just keep going, because when going gets tough, just keep going. And yeah, it was a lot harder than I thought it would be, to be honest. It's a tricky thing to get used to. It also breaks a bunch of rules. Like initially, we started to create routes that would, or Lambda handlers that would handle multiple routes, and this did not scale. As soon as we started to break up things into really small atomic units, our life got a lot easier. I think that's the main benefit that you get out of this approach, but it's an entirely new way to architect your application. No, I use Tape, which is a node module. We run everything offline and in memory, and we treat Lambda as a deployment target, as a last step. But we also, another weird thing we do that I'm not aware of many people doing is that we deploy 2 Lambdas for every piece of code. And one's staging, one's production. So we have total isolation right down to the function level. Lambda shipped with this idea of stages that was just super janky to work with between API gateway and it. And then they added environment variables, and we were like, oh fuck, we need environment variables. We want those. Because a lot of node modules depend on node env. And so then we're like, why don't we just deploy 2 Lambdas? One for staging, one for production. And that turned out to be really awesome for us. And then we mock out DynamoDB with Dynalite, and we sort of fake out our routes with Express. We just run it offline. That's it. So we run the whole. I ran it the other day, and I was pleasantly surprised. We have a few hundred tests, and they run 10 seconds. I've got like a short term and then a long term on that one. So in the short term, I think we're going to see resistance. People right now are like, the hype cycle is like hit, and we're in the trough of disillusionment. There's people that aren't even sure if this is a thing yet. Docker and Kubernetes talks are being like totally packed. Well, people are like, is serverless a toy? And I've got massive pattern matching to my early experiences in mobile with this. So I think in the short term, we're going to suffer a little bit of fear, uncertainty, and doubt. And then I think slowly, like a rising tide, people are going to realize that configuration management and server management is the wrong metaphor. So it's not a problem with deployment. It's not a problem with the technology. The problem is the metaphor is wrong. And functions as a service and these serverless-y things where you have this isolation of these little bits, that's the big deal. And that's going to take a bit to sink in. So I don't know how long it's going to take. I thought Cordova would be finished in like 2012 and still going strong today. So I have no idea about timelines. I'm bad at estimating. I'm a software developer. It'll be all over in 50 years. Thank you.